Hi everyone, welcome to the final lecture on the Introduction to ML chapter by egate.ai. I am Amrith, and in this lecture we will look into dimensionality reduction and unsupervised learning paradigm. Before starting the lecture, we have an important question to address. In our first and second lectures, we saw few task formulations using movies, or more specifically, pertaining to the box office collection of movies. Specifically, we have looked into how we can formulate regression, classification, and clustering, all using movies as input. For as humans, it suffices to be shown an image or a poster of the movie. We easily can obtain relevant facts of that movie to estimate its box office collection. Further, we are quite adept at ignoring irrelevant information that does not help us in our task. But how do we represent these movies in a manner that makes it easy for machine learning system to comprehend and aid in making the right decisions? So there are two questions here. How do I represent data about the inputs? In this case, we are talking about movies. That helps a machine learning algorithm understand it. The second question is, how do I ensure that only the relevant information is added? We need to understand while there can be humongous amount of information about a movie, a lot of it need not be relevant to the box office collection of the movie. So we need to identify the right type of information that can help the machine learning algorithm to make the right decision. As an analogy, think of it like selecting the right camera angle and posture before we take a selfie. So, what would be a good representation? And representation of what? A representation of the input. And to obtain this, we will come back to this later, but let's look at some of the simpler examples which we discussed previously. So we might have seen this question as is in our third lecture. And the question reads as follows. Predict the rank that a student may get in GATE based on their performance in BTech. So we might know that our target variable, which is the value to predict, is the GATE rank, and our input is BTech performance. So in this question, the variables that needs to be mapped are given explicitly. So for each student, let's say student 1, student 2, student 3, we can represent our data as a row consisting of two values, or the overall data set can be represented as a table of two columns. One column for the BTech performance and the second column for the rank. Now, the BTech performance may be represented as percentage of marks, such as say 80%, 93%, and 88%. Further, we can provide the rank as 50, 200, 130. So this table tells us that a student who scored 80% in BTech obtained a rank of 50, a student who obtained a BTech percentage of 93% obtained a rank of 200, and S3 who obtained a BTech percentage of 88 got 130 rank. Now from this information we have to find a mapping so that for a new student, let's say S4, whose BTech performance is, let's say, 87 percentage, we need to predict the rank, the gate rank.